In this lecture, we will discuss about some properties of the Bessel's function. In the previous lecture, we have already discussed about Bessel's equation and the solution of the Bessel's equation. And in this lecture, we will discuss about different properties of the Bessel function. So, Bessel function Jnx can be written as r equal to 0 to infinite minus 1 to the power r divided by r factorial gamma n plus r plus 1 and x by 2 to the power n plus 2r. This is Bessel's equation. And if we write that is minus x in place of x, then this will become Jn minus x is equal to r is equal to 0 to infinity minus 1 to the power r divided by r factorial gamma n plus r plus 1. And as we have written minus x in place of x, so we will write minus x in place of x, that is minus x by 2 to the power n plus 2r. This is equation 2. Now we will discuss about two cases, that is when n is even and when n is odd. So in the first case, if n is even, then n plus 2r is even, because 2r is an even number, n is also even, so n plus 2r is even. So minus x by 2 to the power n plus 2r will be definitely x by 2 to the power n plus 2r. Why? Because n plus 2r is even. Now this is the expression for Jn minus x. This is the expression. So in this expression, if this term, that is minus x by 2 to the power n plus 2r, if this becomes this one, that is x by 2 to the power n plus 2r, then there will be no difference in the expression of Jnx and J minus x. You see the expressions again. But here there is a minus sign that is misprinted here, and there will be no minus sign over here. Just you understand in this way, that is this term in the first bracket minus x by 2 to the power n plus 2r, that can be written as x by 2 to the power n plus 2r. So Jn minus x and Jnx will be equal. So Jnx is basically even function, and when n is odd, then n plus 2r is also odd. So minus x by 2 to the power n plus 2r, that will be minus of x by 2 to the power n plus 2r. So Jn minus x will be, we will write minus of this one in place of this first bracket. So minus sign will come at first, then this one is minus 1 to the power r divided by r factorial gamma n plus r plus 1 x by 2 to the power n plus 2r, that is minus Jnx. So Jn minus x is equal to minus Jnx. So Jnx is an odd function. So this is one of the property. And another property is this, that is we can show that limit x tends to 0, Jnx by x to the power n is equal to 1 by 2 to the power n gamma n plus 1. This is very simple, because we have already deduced the expression for Jnx. So Jnx is equal to x to the power n divided by 2 to the power n gamma n plus 1, 1 minus x square by 2 into 2n plus 2 plus x to the power 4 divided by 2 into 4 2n plus 2 into 2n plus 4 in this way. So we can write Jnx divided by x to the power n, that is x to the power n, we are keeping it on the left side. So Jnx by x to the power n is equal to 1 by 2 to the power n gamma n plus 1 and 1 minus x square by 2 into 2n plus 2 plus x to the power 4 divided by 2 into 4 into 2n plus 2 into 2n plus 4 in this way. But if we put limit x tends to 0, what will happen? All these terms will be 0. So in the right hand side, we will obtain only 1 by 2 to the power n into gamma n plus 1. Now we will discuss another some properties. For example, we have to show j half x is equal to root over of 2 by pi x sin x, and j minus half x is equal to root over of 2 by pi x cos x. So this is the expression for the Jnx. We have to memorize this expression for the Jnx, and if we put n is equal to half in this expression, so this expression will become like this, that is j half x is equal to x to the power half divided by 2 to the power half gamma half plus 1, and here 1 minus x square divided by 2 into 2, and we will write half in place of n in all these terms. So after simplification, this will become in the third bracket, that is for this second term, this will become 1 minus x square by 2 into 3 plus x to the power 4 by 2, 3, 4, 5. Basically this is 3 factorial, this is 5 factorial. So actually this is becoming in the third bracket x minus x cube by 3 factorial plus x to the power 5 by 5 factorial. We have taken 1 by x common for this expression. So ultimately actually the series in the third bracket, that is the expression for the sin x. So this is we are writing this series as sin x. So ultimately we are having root over of 2 by pi x sin x. So this is the value of j half x, and in the similar method we can also calculate j of minus half x. We have to write minus half in place of n in all these expression. So if we proceed in the previous manner, so we can have, that is 1 minus x square by 2 factorial plus x to the power 4 by 4 factorial in this way, and this series is actually cosine series. And here point to be noted, that is we have started this expression from by using the expression here, that is this expression, this one. So j half x is this one. So j minus half x will be just we have to put minus half in place of plus half. That is, in this expression they have used minus half in place of plus half. So they used this expression for the calculation for the next example. So for n is equal to minus half, it is advised to use this expression. So then it will be very easy to calculate the terms. So ultimately we can show that the terms in the third bracket, that is actually cos x. So j minus half x is equal to root over of 2 by pi x into cos x. Now we will show that is what is the expression for j 3 by 2x. So we will proceed in the like in for the previous example. So at first we have written the expression for the j n x, that is equation number 1. Then we will put n is equal to 3 by 2 in place of n. So here we have done that. Now in the third bracket we are obtaining like this, x square minus x to the power 4 by 2 into 5 plus x to the power 6 by 2, 4, 5, 7 in this way. But here we have to apply a special tricks so that we are able to calculate the value of j 3 by 2x. So what is the trick? At first we have to simplify the coefficient here, that is this first term. At first we have to simplify. So this will become root over of 2 by pi x, and 1 by, there will be 1 by 3 that you have to multiply with the third bracket. So you have to multiply that. So the coefficient is root over of 2 by pi x, and this is the series in the third bracket. But here if you observe carefully, you see that that x square term, basically this is x square by 3, because after multiplication from this coefficient, so that term has been written by the subtraction of two terms, like x square by 2 factorial minus x square by 3 factorial, and this term, that is x to the power 4 by 2 into 5, that is 10. We are writing this term as a subtraction of these two terms, like x to the power 4 by 5 factorial minus x to the power 4 by 4 factorial, and this term, that is x to the power 6, we are writing as x to the power 6 by 6 factorial minus x to the power 6 by 7 factorial. In this way we will proceed. Then what we will do, we will separate the series in two terms. The first term will be like this, 1 by x, x minus x cube by 3 factorial plus x to the power 5 factorial in this way, and the second series will be 1 minus x square by 2 factorial plus x to the power 4 by 4 factorial in this way. Actually we have to keep in mind that is first series is for sine series and second series is for the cos series. So we have to arrange these terms accordingly. So this is 1 by x sin x minus cos x. So we can show easily, that is root over of pi by x by 2 j3 by 2x is equal to sin x by x minus cos x. And in the similar manner we can also calculate the value of j minus 3 by 2x. So we have to proceed in the similar manner. Just what we have to do, we have to do one extra task, that is we are multiplying numerator and denominator by n plus 1. Here for simplification purpose we have done that. Next what we will do, we will put the value of n is equal to minus 3 by 2 in this series. So we are obtaining like this. So this is the series in the third bracket. So we have taken 1 by x common here. Then we are writing this series in this way, that is to obtain two different terms, we are writing in this way, that is suppose for example this is 1, but for x square by 2, that is x square by 2, we are writing in this way, that is x square into 1 minus half. And for this term, that is x to the power 4 by 2 into 4, we are writing in this way, that is minus x to the power 4 1 by 6 minus 1 by 2 into 4. Actually this we are doing for a special purpose. So next what we will do, we will separate this series into two different series. For example, for the first series this will become minus 1 by x into 1 minus x square by 2 factorial plus x to the power 4 by 4 factorial in this way. And in the next series will be like this, minus of x minus x cube by 3 factorial plus so on. Actually we have to keep in mind that we have to separate the series into different terms. Actually one expression for cosine x and another expression for sin x. In that way we have to rearrange this series. Rearrangement done in this way, actually we have to understand, that is this series will be divided into two separate series, one for cos x and another for sin x. So that is why we have proceeded in this way. So ultimately we are having, that is root over of 2 y pi x minus 1 by x cos x minus sin x. So we can show that root over of pi x by 2 j minus 3 by 2x is equal to minus 1 by x cos x minus sin x. So this content is from the book of Das and Verma, and I advise you to read this book for further understanding. Thank you all who have listened the lecture.